Making the apparatus for Charles's law experiment, we have a capillary tube sealed at one end only. Part way along is a bead of concentrated sulphuric acid. This capillary tube is attached to a steel ruler so that the scale can be read through the tube. The end of the tube is covered with the cut-off bulb from a teat pipette to prevent the acid absorbing water from the atmosphere. The cap is removed when performing the experiment. The sulphuric acid in the capillary tube must be close to 100%. It absorbs all water in the trapped air. We inject the acid into the capillary tube using a long, fine Pasteur pipette. To make this Pasteur pipette, use some soft glass tubing. Heat the middle in a strong flame until very soft. The process shown here actually took 2 or 3 minutes. You want to have a couple of centimetres of very flexible glass. Quickly withdraw it from the flame and at the same time pull out by about 10 centimetres. The thin section cools and hardens very quickly. Break the thin section. You could score it first with a blade or knife. Here's a nice long Pasteur pipette with a rubber suction teat fitted. I'll put it in this stand. And have a small amount of acid in a beaker. You don't need nearly as much as shown here. Put the pipette in the acid and squeeze the bulb just a little. The acid is quite viscous, so you need to leave it for a minute or two to be pulled up into the pipette. Then, to inject the acid into the capillary tube, it takes a steady hand to line up the pipette and the capillary. I usually prefer to do this horizontally. Inject a bead about 1/3 of the way down the capillary and make the bead about 10 millimeters long. Place the end cap to prevent the acid absorbing water from the atmosphere. And here's a close-up of the injection process. Here's a nicely done one. But if the bead is broken like this, you can still use it. If the bead grows to 15 millimeters or more, it has absorbed too much water and needs to be renewed.